dy over
dy over dx.
Perfect. Good. So then in this case, the first piece changes into t times x to negative 2. The second piece doesn't have to change at all because this is 1 over t times x. So what I did, I emphasized what I'm interested in. X here is in the denominator. I will have to differentiate it. Oh, sorry. So x here is in the denominator. I have to differentiate because we chose to differentiate with respect to x. So then this has to be presented as t times x to negative 2. Here, I'm differentiating with respect to x. So 1 over t is a constant in front of x. X over t is the same with 1 over t times x. So always try to emphasize and make your life easier from the beginning. Okay, now, when I differentiate this, we already told me, bring down negative 2. So I have negative 2t times x, as you just told me, x to negative 3. And that's done. 1 over t is the slope of x. This is a constant. So a constant times a function prime. But what is the derivative of x?
One.
Very good. So this all we have is 1 over t. So this final form is negative 2t over x cubed plus 1 over t. Done. Any questions on this? Any questions? I plugged in my laptop. I was running out of juice.
Can we do it the other way too?
Yes.
dy over dt?
Yes, it's the same thing. This will become sort of this and the other way. So now this is just 1 over x squared because t prime is 1. Now this one is positive x and 1 over t prime is negative 1 over t squared. Because 1 over t prime, we already know. 1 over x prime is negative 1 over x squared, or 1 over t prime is negative 1 over t squared. So this is 1 over x squared minus x over t squared. We differentiated this time with respect to t. Good. Any questions on this? Any questions on this? Any doubts? Anyone? Okay, I'd like to look at something with a tangent. We can choose a tangent from here, or we can choose a tangent line and a normal line. Let's start with a tangent line. I don't know, let's start with 38. The 38 we have y equals 2 e to the x plus x. So they're asking us to find the equation, not just the slope of the tangent line, but also the equation at the given point. So I know y minus y1 equals the slope times x minus x1, where x1 is 0, y1 is 2, but I have to determine this. How do I determine the slope at 0? How will I find the slope at 0? The slope of the tangent at x equals 0 is nothing else but f prime of 0, which is this. This is our f of x. How do I find f prime of 0? What do I have to find first?
F prime of x.
Yes. So can anyone help with f prime of x?
2 e to the x plus 1.
2 to the x plus 1. Now we can find f prime of 0. Can anyone give us the answer for f prime of 0? That's it. E to 0 is 1. 1 times 2 is 2. 2 plus 1 is 3. So then I have y minus 2 equals 3 times x minus 0. So y equals 3x plus 2 is the equation of the tangent line at 0, 2. Of course, tangent line to the graph of y at 0, 2. So if this is the point 0, 2, this line has a slope of 3 and an equation of 3x plus 2. That's all it means. Okay. Okay, so let's talk about the tangent line and the normal line. Okay, would you like to choose? Okay, 41. Y equals x to the 4th plus 2 e to the x, and it's 0, 2. So I'm not graphing this function. So I'm just saying this is a function, f of x. And let's say this is a point, like this one. This is the tangent line, tan at P. And the line that is perpendicular to this one, this line, is normal at P. So at a particular point on the graph of a function where the function has a tangent, of course, this is the equation of the tangent line, and the perpendicular one is the equation of the normal line. So 4 90-degree angles. If I manage to determine the slope of this, let's say, as an example, what if the slope is 1/2? I'm going to erase it, don't even write this. What will be the slope for the normal line? For them to be perpendicular.
Inverse.
Yes, but negative. So remember, m1 multiplied by m2 has to equal -1 if they are perpendicular lines. I'm sure you remember it as m1 equals -1 over m2. It's the same thing. I just like to cross multiply, and I get this. Why? Because it's so much easier to say the product is -1. What you normally say, m1 is the negative multiplicative inverse of m2. Who cares? The product is -1 for perpendicular lines. If you want to remember it like this is perfect. But this is so much easier. The product has to equal -1. The product of these two numbers equals -1. That's why they are perpendicular. Okay, enough of that. So let's determine the equation of the tangent line, and then determine the equation of the normal line. So I have y minus y1 equals the slope times x minus x1, where I have again 0, 2. They are in love with 0, 2. So how do I determine the slope of this tangent line?
Find f prime of 0.
Yes, so we have to find first f prime of x, which is 4x to the third plus 2e to the x. And yes, then we have to find f prime of 0. This is 0, this is 1, so the slope is 2, so I have to put in here 2. If the slope of the tangent is 2, what is the slope of the normal? Normal. I had no idea that we're going to get 2.
Negative 1/2.
Negative 1/2. Thank you so much. Okay, so then I plug in 2, so y minus 2 equals 2x, and y equals 2x plus 2 is the tangent. But for the normal, I use the same thing, but instead of the slope for the tangent, I have to put in the slope for the normal. So y minus 2 equals negative 1/2 x. And then y equals negative 1/2 x plus 2. So this is the normal. This is the normal line, which is perpendicular to this one. They are perpendicular to each other. The tangent to the graph and the normal line. Any questions on the tangent and normal? Okay, so let's look at now some word problems and discuss. I like to look at 50. We can find second derivatives, but I'd like to look at this one, 53. In 53, we have s of t, not s, but s of t, clearly, t cubed minus 3t. And we're told that s is in meters and t is in seconds. Perfect. Find the velocity and acceleration as function of t. So, in part A, we want to find the velocity. So what does the velocity represent here? I have the distance formula. What will the velocity represent for the distance formula?
The derivative, so s prime of t.
Very good. It's s prime of t. The rate of change of the velocity with respect to time. Rate of change of distance. I think I said velocity. I'm sorry. Rate of change of distance with respect to, that's how lazy people write, with respect to time. So let's find v of t. Can anyone give us v of t? Anyone?
3t squared minus 3.
I know that not only Caitlin is paying attention. Okay, what about the what about the measurement unit? I want to write the measurement unit for velocity. It's a rate of change.
The derivative.
The measurement unit. This is a rate of change. It has to have 2 measurement units. Any rate of change has to have 2 measurement units.
Distance and time.
But what is the measurement unit of distance?
Meters per second.
That's why I wrote them. Now we want to determine the acceleration. What does the acceleration represent? And how do we determine it?
Take the derivative of the velocity.
So this is v prime of t. but also the second derivative of the distance. What would be the measurement unit for acceleration? We have to give me two measurement units. Is the rate of change of velocity with respect to time. And it cannot be this. The rate of change of this with respect to time. Anyone else?
Is it meters per second squared?
Thank you very much. Good, so now let's determine it. Awesome. Can anyone give us a derivative of the velocity or the second derivative of the distance? Anyone?
16.
What is the derivative of -3?
0.
0. The derivative of a constant prime is 0. Please remember that. It doesn't change. There is no rate of change for a constant. Poor constant. Good, so let's see what else they want. Find the acceleration after 2 seconds. Fine. Can anyone give us the acceleration after 2 seconds?